This is the full-size model of the Giotto spacecraft on display at Aerospace Bristol. Giotto's mission objective was to intercept Halley's Comet, to obtain images of its core, and to obtain detailed data as to its composition and processes. The spacecraft is named Giotto after a 14th century Italian painter. The spacecraft was developed from the GEOS research satellite and was built by British Aerospace at the Space Centre in Filton, Bristol. It was launched by an Ariane rocket on the 2nd of July 1985. Giotto is 2.85 metres in height and 1.1 metres in diameter. It weighed almost a ton at launch. Comets are the icy remnants left over from the formation of the solar system. They range in size from a few miles to tens of miles wide. Comets are mostly made of ice and dust. Think of them as very dark and dirty snowballs. They normally reside in a cloud outside of the orbits of the planets. However, occasionally, a comet will get a gravitational nudge which will divert its orbit much closer to the Sun. As the Sun heats the comet, it will eject dust and gases to form the characteristic tail of debris, which can be millions of miles in length. One of the best known is Halley's Comet, which is visible from Earth once every 76 years. These visits from Halley have been recorded many times throughout history. Here it can be seen in the Bayeux Tapestry, when King Harold was defeated by the Normans in 1066. This picture was painted by Giotto himself and is called the Adoration of the Magi. It shows Halley's Comet above the stable at Bethlehem, leading the three wise men to the Nativity. It is widely believed that Halley's Comet was the Christmas star.
4, 3, 2, 1.
Ariane 1 was an early version of the European Space Agency's multi-stage launch rocket. The rocket stood 50 meters tall, and its 4 Jupiter engines of the first stage produced a thrust of 2,771 kilonewtons, which is more than 16 times the thrust of a Concorde Olympus engine. After 45 seconds, the first stage had burnt all its fuel and was jettisoned, and the second stage engine takes over. Once the Ariane rocket climbs above the atmosphere, Giotto's protective fairings are jettisoned. Stage 2 is then jettisoned when its fuel is consumed, and Stage 3 takes over, accelerating Giotto into a geostationary parking orbit. After 3 orbits of the Earth, Ariane's third stage is fired again to accelerate Giotto further, and then Giotto separated from Ariane and fired its own small maneuvering rocket engine. This sent Giotto into an extended elliptical orbit. The journey to intercept Halley's Comet would take 8 months. This was the very first deep space mission for the European Space Agency. Giotto joined an armada of 4 other spacecraft heading towards Halley's Comet. 2 Japanese and 2 probes that were a joint project between France and Russia. As well as collecting their own scientific data, they were pathfinders for Giotto to determine the exact position and velocity of Halley's Comet and to allow for the closest possible encounter. Let's take a closer look at the Giotto spacecraft. On the top of the model, you can see the radio dish, which was used for communication back to Earth. This is actually the rear of the spacecraft in flight. The main body of the spacecraft is covered in solar cells to power the experiments. The spacecraft would spin at 15 revolutions per minute to stabilize it during flight. This image shows the interior of the spacecraft. The large silver spheres are propellant tanks. Beneath them is the instrument bay. Giotto carried 10 instruments, which included a multicolour camera, mass spectrometers, dust impact detectors, plasma experiments, energetic particle analyzer, and a magnetometer. The main colour camera can be seen projected from the bottom, that is the front of the spacecraft. The bottom of Giotto is a large aluminium plate. This is the front of the spacecraft in flight. The panel is to protect the spacecraft from dust and debris from the Comet. There is also an additional shield made of Kevlar to provide additional protection. This plate is also the particle detector. When a particle from Halley hits the aluminium plate, it will ring like a bell, and counting the rings provides data on the amount of debris coming from the comet. Many impacts were recorded. 35 years ago, on the 14th of March 1986, Giotto passed Halley's Comet successfully at 596 kilometers distance, and surprisingly survived, despite being hit by many small particles. One impact, just before closest approach, from a particle of just 1 gram, but travelling at 68 kilometers per second, sent Giotto spinning off its stabilised spin axis, so that its radio dish no longer was pointed at the Earth, and its dust shield no longer protected its instruments. Some instruments, including the colour camera, were damaged. After 32 minutes, Giotto restabilised itself and continued gathering science data. This is an image from Giotto of Halley's core, taken at 596 kilometers distance. The outflow of gas and dust is clearly visible. It revealed the core was 15 kilometers long and 7 to 10 kilometers wide. One of the main surprises from the Giotto mission, though, was the discovery that comets are not actually dirty snowballs, but are mostly composed of dust with the ice embedded, which makes up 80% of the mass of the core. The dust particles are rich in hydrogen, carbon, nitrogen, and oxygen, and surprisingly organic material. Perhaps these are the building blocks of life. The remarkably resilient spacecraft surprisingly survived the hailstorm of particles during its encounter with Halley. Over 12,000 impacts were recorded by the particle detector. Giotto did suffer some damage to its instruments, and the colour camera was completely destroyed. After its Halley encounter, Giotto still had some fuel remaining, so it was retasked to intercept a second comet. The spacecraft was then placed into hibernation to protect its instruments and to save power. On the 2nd of July 1990, as its orbit swung back towards the Earth, Giotto used the gravity of the planet to change its trajectory and velocity towards the comet Greg Malpas. This was the first time a gravity assist had been used on a deep space probe. It approached the comet Greg Malpas on the 11th of July 1992, coming to within 200 kilometers of its core. Giotto was deactivated on the 23rd of July 1992, although it is still travelling somewhere in deep space. Giotto was notable for a number of firsts. It was the first European Space Agency deep space mission. It was the first comet encounter. It was the first gravity assist course maneuver. And it was the first spacecraft to be placed into hibernation for part of its mission. Don't forget to make a note in your diaries for the year 2061, which is when Halley's Comet will be visible from Earth once again.